there are two, well, let's say 4 more identities. Mr. Cheng, I need your attention. There are 4 more identities, especially for sine and cos, that we need to know. I think they are also in the examination booklet, so there will be no need to memorize or anything like that. So, but it would be nice if you know it. Please, Leo. So, what do we call addition formula in trig? Some call it maybe some other name, but I like to call it, some call it compound angle formula. So, sine of A plus B. Actually, we can compress it, but I'll write it in full first. It's sine A cos B plus cos A sine B. For in the case of minus, you just change the minus in between them, the plus in between them to minus. So it's possible you check some textbook and you write sine A plus or minus B, and this is plus or minus also. They compress 2 in 1. Is that clear? Now the cosine is a bit different. The case of plus gives minus and the case of minus gives plus. There are proofs for these things, but the proof is not required for us to know, so I'm just going to write the results. Is that clear? And similarly, cos A plus B. So in the case of sine, this is the pattern, because you can see I'm writing this without looking at any material. So how did I learn this? Say about 19, 20 years ago. I studied patterns. The proof was not required in my time too, and there was no examination booklet that I can look at in the exam. So I noticed that sine is always a mix of both trig ratios. But cos is a bit selfish. Cos puts its own people first. So the first one has cos A cos B. You can imagine. But while sine is a bit, it has inclusive property, sort of. Okay, you can come and dine with us. We don't have to put our people first all the time. So it's a kind of a mixed society. Why this is like, nah, you guys stay over there. So why we stay over here? And our people first, then you guys can go the other way. Something like that. So cos is a bit biased, isn't it? Very, very biased. So for the minus, it's also cos A cos B plus sine A sine B. So cos is not only biased, cos is confused and it's inconsistent. Why did I say that? Sine, you can mix, and when it is plus, of course, you can have plus. When it is minus, so there's consistency to avoid confusion. But this dude right here is not just biased. I don't like people who like coffee. I don't like people who, sorry, I wasn't talking about you. Then also in the case of plus, it changed to minus, minus changed to plus. So just remember, and if you remember in the sine and odd and even function, cos is the only black sheep of the family. Cos minus x is cos x. The minus just disappear with no reason. So the guy is like a maybe dictator, military dictator or something like that. Anyway, that's none of our business. That's how they want to run their thing. So if you remember this, you don't have to memorize tan because we can actually generate tan. So if I'm going to give you a test, I'm going to tell you, given that sine A plus or minus B is this plus or minus this, given and cos A plus or minus B is this minus or plus, so there will be plus under. This is plus or minus, this is minus or plus, which means the first case is minus, the second case is plus. Do you understand what I mean? So if I give you this 2, then I can say, show that tan A plus B is equal to something. So this will be the preamble, and you have to establish tan. So we're going to establish tan together. Okay? So we may not do a lot of applications today because we have very little time. What I want us to do today is establish these facts, and when we now meet tomorrow and we're trying to use the application, then it makes more sense. Okay? So come with me as I do for tan. So for tangent, for tan A plus B, now, we use sine theta over cos theta equals tan theta. Do we remember this? Okay. So which means, let's write it together. What will tan A plus B be in this case? Good. Sine A plus B, over cos A plus B, right? Okay? So then we try to write what these are based on what we have done so far. Guys, can I ask you to do this with me, please? So what is the numerator? Sine A cos B plus cos A sine B. And what is the denominator? Cos A cos B minus sine A sine B. Now when you say this thing each time, it sticks in. Not just look at it once or just copy the note later. That's why I need it to be part of it. The note can always be written later, okay? So, we need to establish something in terms of tangent. But this is not looking at tangent. We have used a trick in the past. Say you are trying to simplify x is equal to a over b, but you are not allowed to divide both sides because you just want to simplify this. We use a trick at the point where we do times 1 over 1 doesn't change anything, remember? And we say, oh, maybe this can be a over b divided by a over b. Or even 1 over b divided by 1 over b. Doesn't change anything, right? Oh, times, I mean. Right? Then we say this goes up and this comes down. Do you remember this trick? We haven't changed anything because we only multiplied by 1. Whenever you multiply 1, which means numerator and denominator is the same, you didn't change anything on any side. And that's a trick to be applied here. The idea is to have something in terms of tangent. How can you achieve tangent? By having sine divided by cosine. Am I making sense? Sine divided by cosine. Sine is here. We need a cosine below it, which means we need a cos A below it. Right? We don't care about this guy. Sort of. But look at this. This is cos. Not a problem. We need a cosine of B also. So for every sine, there is need for cos A and cos B, right? So we need cos A here. Oh, maybe cos B can get rid of cos B. We have a cos A here. Oh, it cancels. Oh, maybe cos B can give us a tan. Do you understand my point? And similarly here, cos A cos B, oh, this will give us 1. We don't have a problem with 1. We just do not want anything in terms of sine and cos. Are you getting my point? This is why we will multiply. Instead of 1 over 1, we multiply by 1 over cos A over cos B, 1 over cos A over cos B. Do you understand? So it looks as if we are dividing each of these by cos A cos B. We are not dividing, we are multiplying by 1. Okay? So this will be sine A cos B plus cos A sine B. Then cos A, cos B, Miss V, do we get this part? Times, can you see this? Times 1 over cos A cos B, 1 over cos A cos B. This is 1, so it doesn't affect our left hand side. So, and when this goes into each of these binomials, it makes it look as if we are dividing, but we are not dividing. Remember, you can only divide if you are dividing both sides. But here, there is no both sides. There is only one side. This side was interpreted to be this, which was interpreted to be this. So it's not one side all the time. Do you get that? Anyways, this becomes tan A plus B, equals to, what does the first one become? Sine A cos B, talk to me, divided by cos A cos B. Then plus the second one, we are still at the numerator. Understood? The second part, which is this, cos A sine B divided by cos A cos B. Okay? Then cos A cos B, right? Divided by cos A cos B minus sine A sine B divided by cos A cos B. And what does this become? maybe we can write the answer now directly. So which means the addition formula for tan A plus B is equal to, yes? What's the first part? Are you confused? You don't need to look at this anymore. This is where we are now. Because this gives what? Tan A. What about the second one? Cancel, that's 1. So you have tan A, good. Plus, what about this part?
Tan B.
Are you sure? Because cos A is gone. So you have tan B. Then here, 1. Minus tan A, tan B. And that is one of the addition formula for tan. Okay? So, I'm going to write for tan A minus B. It's just going to be change of sign. Remember, the only difference is this will be minus and this will have been plus. If this is minus, this will be minus. If this is minus, this will be plus. So the only thing that will change here is also minus and plus. Okay? And I want you to prove this. So the amount of space required to do this, I need you to leave that space and generate the second yourself. I'm just going to write the report. So it says similarly, tan A minus B equals to, so I need you to do that until you arrive at the result. Tan A minus B equals to, so this is DIY. Understood? That's DIY. Let's take note of this quickly. I'll just give you like 3 minutes to write as much as you can. You don't have to do this DIY now. Please, you can do that later. And you're going to be free on Monday and Tuesday anyway, according to you. So you have enough time to do whatever this weekend and then. Is Miss Krista still there? What am I doing? Okay, she's still there. Do you understand what I've done so far? Okay. So let me know if there's anything later on WeChat, okay? All right, can I ask you to pause for a minute because we only have 24 more minutes. Double angle. What do we mean? What does double stand for? Okay, what? 2. So double angle formula means what is the identity for sine 2 theta, cos 2 theta, tan 2 theta. We use A and B here because we mean for different values. It doesn't have to be equal. So, but by the time we say sine 2A, we're actually referring to the case when A is equal to B. Do you agree with that? So we're going to derive our double angle from the addition formula. In particular, using this, and then just establish this. Does that make sense? Okay? So, sine of double angle is just one identity. But cosine of double angle gives 3 different identities. While tangent for double angle is also one identity. But all these do not need to be memorized. Okay? Once you can remember this and this, you will check the examination formula sheet. If anyone that is not there, then you need to really take note. But by the time you actually use this to know, okay, can I have What is the first trig identity that we did that has to do with square square? Sine square plus cos square. You see? Because you have used it now in some series of examples, now you know. The same applies to some of this, so you don't need to panic. Okay? Alright. For sine, cos, and tan, so I will say here, we deduce identities for sine 2 theta, cos 2 theta, and tan 2 theta. Of course, I could have said sine 2a, cos 2a, tan 2a. It doesn't matter. Okay? I just wanted to not look exactly like this. The first one, from sine a plus b. Can we try to state sine a plus b without looking at that part of the board? Sine a cos b plus cos a sine b. Wonderful. So from here, if a is equal to b is equal to theta, okay? If a is equal to b is equal to theta, then it implies that what? Sine theta plus theta, that is on this side, okay, is equal to, complete the rest for me, sine theta cos theta plus cos theta sine theta. Are these the same? So this is like xy, this is like yx. So what does that give you? This is sine 2 theta equals what? 2 sine theta cos theta. And that is the identity for sine 2 theta. This you're going to need, especially in calculus. So many differentiation we come up with trig functions, and the best thing will be to manipulate with the identity. That is why I put this topic before calculus. Okay? Similarly, can I ask you behind your notes to establish something for cos 2 theta? Everybody, 3 minutes. Leave this maybe on the rough paper or whatever. Try to establish something for cos 2 theta, quickly. I hope I'm not obstructing our view too much. Okay, she can see. I believe she can. This is what she's seeing, right? So that when I'm writing, I do not obstruct our view. Yes.
What are we supposed to establish?
Cos 2 theta.
Oh, okay.
Yeah. You do the same for cos 2 theta. Let me know when you're ready. You got something? No. Cos times cos is not 2 cos. That's cos plus cos. Ah. No. So this is how we write that. Not. Okay. This looks like you square the angle, but cos theta is being squared. Perfect. Yeah. Now this is one of them. With your previous knowledge, can you now establish 2 more equivalents of this? Equivalent statement. Good. Wonderful. Simplify that. So you get 1 more equivalent, making 2 now for cos 2 theta. Then establish 1 more. She's getting what I want. Yes. Cos times cos is not 2 cos. I've seen that in 2 places now. It's cos squared.
Oh.
That's it. So with this, can you establish 2 more equivalents of that identity?
Anybody have 2 more times?
Huh? So I've seen what you did, so it's about time. This is what most of you have done. Wonderful. So here you say, similarly, if A is equal to B is equal to theta, then cos theta plus theta equals cos theta minus, not B, sine theta. Okay? So which means cos 2 theta equals cos squared theta minus sine squared theta. But we can get two more equivalents of this statement or identity using what? What do we call it? The Pythagorean identity. That was the name. Okay? Remember, using Pythagoras theorem from the circular function of 1 unit radius. Do you understand? So we can get one more equivalent. And what do we mean by that? Can you adjust this for me, Lillian? So you can see what we're doing here. Okay, great. So, but from, I'm going to say sine square x. So you're not mixing all the variables together. Plus cos square x is equal to 1. From here, we have established that sine squared x is equal to 1 minus cos squared x. And at the same time, cos squared x is equal to 1 minus sine squared x. Do you remember this? So in each case, we're going to put it back here and get two more equivalents for double angle for cosine. Hence, cos 2 theta will be equal to, I'm writing this first, cos squared theta minus sine squared theta will now be, if I use the first one, sine is 1 minus cos squared. I'm going to be having cos squared theta minus 1 minus cos squared with a bracket. Why did I put bracket? The negative affects sine squared. If sine squared is now 2 term, the negative should affect both of them. Right? So that will be cos squared theta minus 1 plus cos squared theta. And that gives another identity, which is 2 cos squared theta minus 1. Also, from cos 2 theta equals cos squared theta minus sine squared theta. So I'm going back again to the beginning. And then substitute this. It means cos 2 theta equals, what is cos squared? 1 minus sine squared. Then minus sine squared again. Right? And that gives another identity. Cos 2 theta equals 1 minus 2 sine squared. What do you notice? These two look alike, right? But in case of cos, again, they always come first. You know why? This guy is just selfish, putting his people first. This is how I learned this stuff. I know that cos always brings its own similar whatever first. So it looks like, oh my God, he's so smart. No, I only created a story in my head. You know, and that's helped me out a lot. So I'm going to put this in summary. So while sine is this, therefore, cos 2 theta is equal to cos squared theta minus sine squared theta 2 cos squared theta minus 1 minus 2 sine squared theta. So this is the double angle for cosine. If we substitute directly from here, tell me what double angle for tan will be. Directly from here. Krista, directly from there. And now the laptop is Krista. Tell me, what is the double angle for tan? Just substitute directly from here, without working anything out. You can tell me. Yes?
2 theta.
Tan 2 theta.
Equals 2 tan theta.
2 tan theta.
Over 1 minus tan squared theta.
That's it. Tan theta plus tan theta, 2 tan theta. Tan theta times tan theta, tan squared theta. And that is the double angle for that. And so one of the work that I'm going to give you is, without doing that, I need you to establish the same thing using the relation for this and that, and establish the same thing, if possible. You get my point? I'll write that on the board anyway. So, finally, from tan A plus B equals tan A plus tan B divided by 1 minus tan A tan B. Of course, you don't have to write your tan in capital letter. Okay? But the A and B, if it is angle A in capital, make sure you are consistent the way the question is. If A is equal to B is equal to theta, then tan theta plus theta equals tan theta plus tan theta divided by 1 minus tan theta tan theta. And that gives tan 2 theta equals 2 tan theta divided by 1 minus tan squared theta. That is the double angle for tan. So the homework is, maybe I label this from the beginning. Let's call this this 1. Okay. Let's call this 2. Okay. Your DIY, let's call that 3. Okay. Let's call this 4. Let's call this 5. And let's call this 6. Okay? So I'm going to say using 4 and 5, not using 2. Okay? Using 4 and 5. Here we just use 2 directly. Using 4 and 5, I need you to re-establish 6. That will be the work that I need you to look at yourself. Okay? So, re-establish. So, homework or DIY or something like that, whatever you want to call it. So using 4 and 5, I need you to generate 6 again on your own. Okay? This is 4 and that is 5. So I'd like to see that maybe over the weekend. As soon as it's ready, just send it to me. Of course, this is weekend. Maybe before class on Monday. It's not, yes. Oh yeah. Photo for the board? Yes, please. And send to the group. Our photographer is not working today. Mr. Chen. All right. So can I, for the next 5 to 10 minutes, I'd like to discuss some applications. Have you taken the pictures? Everything. It is zooming. Okay. Not your zoom. So we want to discuss some applications.
The camera's gonna die soon.
What?
The camera's
It's
gonna
okay,
die
we
soon.
still have
It's going to off?
It's gonna die
Soon,
soon.
because
Yeah, there's another
If I
battery.
record now.
I can prepare.
Now record. Record the
Start
video.
recording.
So we can stop that. Venna.
record from there.
Yeah, record from the
Screen
iPad.
No. But I won't be able to upload that. Don't worry. Just you can stop it, then I will change the battery.